And so that way you'll have some time, of course, for your homework, you know the drill, so you can get some of that done in class. I'm going to pause this while it's going to be a long one. Okay, so as you can see, obviously the continuation of yesterday. Like I said, you can see the formula. It is the exact same thing. We're just going to, or we're working our way up to derivatives. So slope of the tangent line, we've seen that can be written as that. Of course, we use this when we do velocities. We're going to talk about instantaneous rate of change at the end today. Sounds super fancy, but of course it's going to be the same calculation. The limit as you approach 0, of course, f of a plus h minus f of a over h. Okay, same thing, we just saw it. Now, notice one other new thing for you. This is not very exciting, but just notice this little mark right there. How you say that is f prime. That is the mathematical symbol that means the word prime. So when you hear me saying f prime, that's the little tick mark and what it means. Notice f prime is the same calculations we were doing yesterday, the derivative. So if I say find f prime, I'm asking you to find the derivative. I might just say find the derivative.
Kill it.
Are you okay, Jackson? Okay. Anyway, we got it. Oh, God almighty. So we got it. That's cool. Is, of course, the same calculations we were making yesterday. So you're going to do the limit as, of course, I get seniors waving at me at the door there a second. Okay. So sorry for the distraction. So you're going to do the limit, same thing as yesterday. And again, sometimes we have to be careful with our direct substitution, because of your 0 under the line. So same deal. I might have to do any factoring. I might have to rationalize the numerator. All of the same rules are in effect. Okay. Find the derivative of the function. So we're really asking you to find f prime, and we're doing it at 2. F prime. Okay. And I've already forgotten to throw the word limit in front of here because it's so obnoxious to have to keep writing. Limit. And of course, we're approaching 0. There we go. Now remember, it's really the same thing, of course, as finding like the slope, etc. You're subtracting the y's, y2 minus y1, x2 minus x1. For us, of course, we are putting in 2 for our a, so I'm going to put 2 plus h minus f of 2. And then, of course, we're over that h. So just to click it back a quick slide here. So, of course, a, remember, for whatever reason, I switched the x coordinate variable to a. Same thing. That's the same exact setup we just have going here. Now, we just have to do all the math, pretty much. Setup's easy. We can't go straight, obviously, to direct substitution yet. We need to do some calculating on the top. First, I'm going to have to, this is kind of the pain part of this, do f of 2 plus h. So in our f function, I have to replace both of those x's with 2 plus h, which is going to be a lot of algebra, because we're going to have to FOIL out this 2 plus h. That's going to be kind of a pain. We're going to do 3 times our 2 plus h, and then we have minus 1. Now, I'm going to have to sneak it in there. I'm running out of room. We have to subtract f of 2. Let's just do a little mental math and figure out f of 2 up here. So what is 5 times 2 squared plus 3 times 2 minus 1? Can we get an exact answer?
25.
25.
I said that first.
Good work, Alex. I just heard 20-something. Okay, all right. Now, so I'm going to sneak it in because I'm running out of room because we have minus f of 2. We just figured out f of 2 was 25. So let me sneak in a minus 25 here. That's a sloppy 25 over h. So again, I'm still not ready to do my direct substitution because of the h on the bottom. You'd have 0 under the line. So not hard, just very time consuming to do all this algebra. So first, of course, order of operations, I'm going to do exponents first. We're going to FOIL out 2 plus h quantity squared. 2 times 2. Then you're going to combine our middle terms. We're going to have a 2h, a 2h, so a 4h, and an h squared. Yes, I still have to take 5 through. All right, 3 through the middle, that's going to be easy. 3 times 2, and then 3 times h. 3h. I can't write and talk. 3h. Oh, I need a bigger fraction bar. Okay, we still have minus 1, minus 25. Well, let's just combine those together. I'm going to put minus 26. Lots of terms on the top, lots of terms. Let's take 5 through, of course, and then see what we can put together. And hopefully get to some direct substitution here. So 5 times 4, 5 times 4h, 5 times h squared. And then I've got I'm going to put the 6 minus 26 at least together. So we've got 6 minus 26 minus 20. We've got our 3h still. This is just a whole truckload of algebra. Okay, some stuff, of course, still cancels. The 20s cancel. And we can put the h's together. I'm just going to scroll this up for a quick sec so I'm not clear at the bottom of the screen so we can all see. All right, so limit. We're getting there. You know I like the terms in order. I'm going to put the 5h squared first, and then I'm going to put my 23 h's. And we're close to being ready for direct substitution. You can reduce what out of everything? H.
I knew that. Yeah.
Good work, Alex. And we did all of that work for a final answer of 23.
21. Can you do something for me?
So, is it difficult? No. Is it time consuming?
Very.
Yes. Yes. Especially if you have a lot of algebra to do, definitely. So derivative, we just calculated the derivative, f prime, that is the same thing as the slope of the tangent line. So that's really what this is saying. So of course doing your derivative f prime is the same as the slope, I pretty much just said the exact same thing, of the tangent line at the point. So again, you can always check your answer by looking at the graph and the tangent line and all that sort of good stuff. All right, let's do another. Find the derivative. Why not? We're on the home stretch. Kinda. Okay, but sounds okay. Last word problem's real easy. Real easy. Okay, find f prime of a. We're gonna remember to put the limit on right away. Not gonna forget it this time. Now again, limit. F prime, derivative, same thing as doing the slope. Now, what's a little bit different on this one than the previous ones is just how they have it set up. The last one, of course, just said do f prime of 2. Well, they haven't given you the value yet. That's part B. So for right now, I'm just going to leave it with the variable a in there. We'll replace the a with 1, 4, 9 at the end when I get to that part. So I'm just going to leave it f of a plus h minus f of a, so that's like my y2 minus y1, of course, and over h. Now, we got to do all the work, the simplifying, the algebra, etc. This one isn't too bad.
Promise.
Medium. Because we got to put a plus h in for x, so I'm like, okay, that's fine. Then I'm going to put a in, so square root of a, and of course I'm over h. So this one's kind of bad, a little bad, because right now, I'm just scrolling it up, can you use direct substitution?
0 in the bottom.
Okay, so we need to write this in an alternative form. How can you get an alternative form? Rationalize the numerator, which is kind of a little bit. So we're going to use the same expression, but I'm going to change the sign in the middle to a plus. All right, let's see what we have here. We're going to FOIL out that stuff on the top. Hopefully some things cancel out for us. They should, and make our lives easy. So when I start foiling the top, of course, the square root we know cancels. We're just going to have our a plus h there. The middle terms are going to cancel. So I'm going to skip the o and the I and FOIL. And even the last ones are pretty nice. Square root of a, square root of a. So the numerator comes out pretty nice up there. Now, the denominator for right now, I'm just going to leave the h. I'm not going to distribute. I'm just going to jot all this stuff down because I think some things will cancel. Or I'm hoping some things will cancel. I think we're in good shape. Because, of course, the a's cross off the top. We knew that. And what's h over h going to do? 1. So I'm just going to draw like a giant 1 here. So let's write this a little prettier, because it's kind of a hot mess right now. So I'm going to have 1 left on the top, and then the square root a plus h plus a. I was going to say square root of a. I just forgot to write it there. Work with it. All right, let me scroll it up. I feel like I need a bigger smartboard. Now, I think, oh gosh, I even have to hit extend. Oh boy, okay. I think we can do our direct substitution because if you put 0 in for h, what's a plus 0? A. So we will not end up with 0 under the line. We're going to be okay. So if we put 0 in here, let's clean this up. Forgot the little dot on my eye there. Okay, so if we put a 0 in there, that's out. 1 square root of a plus another square root of a is how many square roots of a? 2. Okay, so like I said, I think we're in good shape. We already put the 0 in. I don't know why I'm still rewriting the word limit here. I already popped the 0 in for my direct substitution. I got it. Now, technically, we're probably A, running out of room on our paper, but technically we should probably rationalize this. But A, we're out of room, but B, look at what B is asking you for. They want you to do, I forgot the numbers, f prime of 1, 4, and 9. I think if I throw a 1, a 4, and a 9, that's going to come out pretty nice for me, right? Because what's the square root of 1? 1, 4, you know. They're all perfect squares. Okay, so I'm just going to leave it because we're really after B, which is clear at the top here. We can't even see it. Maybe kind of try to fit it on the screen there. So let's do f prime of 1. Yeah, so we're going to have 1 over 2 times the square root of 1, so a half. And then let's put in the 4. 1 over 2 times the square root of 4. 2 times 2, 4. And I think our f prime of 6 will come, or sorry, of 9 will also come out pretty nice. We'll end up with 1 over 6. Got it. Yeah. So difficult, new, time consuming. Yeah. They have volleyball and he has to go find his Chromebook.
I found my Chromebook. Well, it's supposed to in 5 minutes, but I lost my Chromebook, and that's kind of important.
He said you know where it is.
Maybe.
So is it lost if you know where it is?
I think I know where
So
it
you're gonna
is.
do walking to Smith's and be like, "Do you have my Chromebook?"
Yeah.
Like, hit it.
Alex, do you want a hard copy of the homework though? Did I give you one?
Not really.
Come get that. Oh, and you want one too? So we got it. Okay. So of course, let's just get on with it, right? Yes.
No.
Is it 4 pages?
I think we should cross some out.
Come on, Owen. All right, moving on. Now,
Alex, she put one on the desk for you. It's right there.
Is it time?
at the end of class, we will take one off.
End of class?
End of class, when it's the end of the day.
Someone record it for me then.
Oh my gosh.
Alex, I will.
Go get your Chromebook. All right, here we go. Now, again, it's all, I feel like we're just repetitively doing the same thing here. It's just difference in vocabulary. But you need to know, you have to be able to read those directions. If it says find the slope of the tangent line, okay, we're doing this. If it says derivative, yeah, we're doing the same thing. Instantaneous rate of change, we're also doing the same thing. Now, this is a throwback way, way back to chapter 2. If you want to get particular, I threw the section up there for you, 2.4. We did average rate of change. Now, average rate of change, remember, is a fancy phrase for slope. y2 minus y1, x2 minus x1. Change in y, change in x. Those are our y's, these are the x's. So we are, of course, smaller and smaller intervals, so we're going to be doing the limit. That should look familiar. I feel like we've written this a million times, okay? Instantaneous rate of change. With respect, gentlemen, instantaneous rate of change is the limit. So here's what's different. We have done just the fraction part back in chapter 2. Subtract the y's, subtract the x's. But now we want to look at smaller and smaller and smaller intervals. So that's where our limit comes into play. That is the same thing. Of course, you have your f prime.
Peace out.
Peace out, Alex. That is the same thing as doing the derivative. So here we go. So again, just vocabulary. Slope of the tangent line, derivative, instantaneous rate of change. It all means the same calculations. So here we go. Here we go. Let's do some word problems. If an object is dropped from a height, I feel like physics class here, of 3,000 feet, its distance above the ground in feet after t seconds is given by that function, of course. Find the object's instantaneous velocity after 4 seconds. Okay, so we are going to find the derivative. And I'm just using h because our function name is an h. And we're looking at 4 seconds. So of course I'm like, taking or thinking about slopes. I'm thinking about subtracting y, subtracting x's on this. So, and we're going to do the limit here of that in a second. Now, we could do a little preliminary calculations on this. So of course I'm going to set it up for us first. We're going to do h of t, which is just our given function, of course, and we're looking at 4. So I am going to have to throw a 4 in there, and I'm going to calculate that in just one quick second. And then, of course, the denominator, you're just subtracting the x's, what you're putting into the function, which in our case is the t and the 4. Now, to do the derivative, I'm going to fancy this up, of course. Remember, the derivative, we're looking over smaller and smaller intervals of time. That's the limit of it all. And we're looking, of course, for 4. So let's kind of set this up. H of t, I'm just going to copy down our function, the 3,000 minus 16t squared. You probably want your calculator to figure out h of 4. So if we put 4 in here, what's 3,000 minus 16 times 4 squared? That's the next value we need. What do you got?
3,000. Oh wait, no. Wrong one.
Jackson for the win. You need a longer fraction bar. Okay.
Yep.
Now, of course, I'm going to combine the like terms on the top, and we'll take a look at it and see where we're at here. So limit, t is approaching 4. I'm going to put the negative 16t squared first. I just like it in the correct order. What's 3,000 minus 2,744? Got it. All right, so the question for you now, can I right now do my direct substitution? No, because we'd have 0 under the line. We're not gonna freak out. We're gonna try to simplify, of course. Like right away, like, oh man, we got some big numbers up top. I think we could probably do a little factoring up there. So next thing I would check, does 16 go into 256?
I hope so.
Sure does. I would like to pull that out. So I'm leaving my t minus 4 for right now. And let's take negative 16 out. Negative 16 goes into 256 how many times? 16. And then I'm like, I'm winning. T squared minus 16 is difference of perfect squares. It factors into t plus 4, t minus 4. We can cross those off. Let's get it done. All those good factoring skills coming into play here. So t squared minus 16, let's make it t plus 4, t minus 4. Oh man, I'm running out of room again. So of course my t minus 4s we can get rid of. Are you ready for direct substitution?
Yes.
Yes. So we're going to put 4 in for t. So I'm really down to what's negative 16 times 8? What's negative 16 times 8?
120.
Got it.
Uh-huh.
Now, it's a word problem, so we should label our answer. Like, what does this mean? What are you finding?
It's 3,000 minus 120. It's fallen 128.
So that's what we're looking at is the speed. We're looking at the rate. So we don't have to get crazy and write out some long wordy sentence here, but let's throw a label on it. This is our rate or speed. What are we measuring the rate in? Feet per second, yeah. And of course the negative just means that it's falling, obviously. Got it. And it feels like we've just been doing the same exact stuff for 2 days straight now, doesn't it? Okay, great. Final one. This one's not bad. Because the tables are going to help you. Because look at this, look at this, look at this. They're helping you out here, my friends. Okay, so let P of t be the population of the United States at a time t. The first table in the margin, table 1, I feel like being away here, gives the appropriate values of the function, providing mid-year population estimates from 2004 to 2012. Interpret and estimate the value of P prime, there it is, P prime 2008. Okay, so of course when we talk about this, it's going to be the limit. We are approaching 2008. And I'm going to set it up. We're going to, of course, subtract our functions, our P of t, our original function, and then our P of 2008. And we're going to subtract our input times t in 2008, or the x coordinates if you want to get fancy about it all. And then I think, Lord, what am I going to do? I'm going to look at this second table. Because don't they have all the values for this in our second table here?
Yeah.
So I don't think I'm going to have to do a whole lot of work here. But notice, they didn't put 2008 in here. They have 2006, 2010. 2008 is in the middle.
5.
So we're going to have to do some little fancy averaging. Okay, so I'm going to add these together, and we're going to divide by 2, and we're done for the day. We're going to average these guys.
Tail, what is it? Jackson.
727,000 something.
Tail.
No. What are we doing?
Add the two numbers and divide them by
I
2.
don't have my calculator out.
Jackson.
2,742,445.
You know, it's Friday. Let's just ballpark it, say 2.7 million. Let's just round. Let's just round. Let's just
All
round.
that work.
Approximately 2.7. We'll save any more reading skills.
Almost guessed.
Okay. So the last word problem of the day was the easiest one because they gave you all that data in the table. Okay? That wasn't that bad, was it?
Yes.
Okay.